This is the direct extrusion process. It is also called forward extrusion, direct extrusion or forward extrusion. So I am showing you a 2D view, right? That this is the billet material, this is the die, this is the container. The ram is coming with a certain velocity or force, and the billet material in the end, in the final shape, is going out with a final velocity and so forth. And in the 3D, you can see this type of a thing, that this is the container, the outermost circle, this is the container, right? And the billet material is there, the billet material. The container has a lining, container liner. And it is from that side now, not from this side, from that side, that this is the press, right? This is the press. And between the press and the billet material, there is a small safety block which is called dummy block, so that the press does not directly come with the billet material, otherwise it may stick to it. And press is a the ram of the press is a very costly thing. So there is just a small block in between them. So this is the press ram, this is the dummy block, and here is your billet material. And this 1, 2, 3, this is the die stack. The die is in several pieces. So this is, for example, the die, this is the die backer. There could be more pieces inside there. And then the material is forced through these, and it takes the shape of the die, and it keeps on rolling out, not rolling out, extruding out. And then there is the pulling chamber and so forth, right? So here we are saying that the starting billet cross section is usually round, cylindrical billet, and the final cross sectional shape of the extrudate is determined by the die opening shape. The die can be any shape. It can be round, it can be hollow round, it can be square, it can be whatever shape. So the billet material will take the shape of the die, right? So this is direct extrusion or forward. Why is it called direct or forward? Because the direction in which the material comes out is the same as the direction of the applied force, right? The force is applied in this direction, and the material also goes in the same direction. So it is called direct extrusion or forward extrusion. Opposite to that is indirect extrusion. So if you see now that the container is there, the container liner is there, and so on, right? But here is the die now. The die is here. But there is a backing disc which is stopping the things. The force is now applied from here. The force is now applied in this direction. And the material, right? This is the billet material. The billet material goes into the die and comes back, right? So the force is applied in one direction. The force is applied in this direction. The material goes through the die and flows back. So that is why it is called indirect extrusion or backward extrusion or reverse extrusion, because you are applying force in this direction and the material is coming back opposite to it, not in the same, right? So it is blocked here, but through the die it is forced back. So that is why it is indirect extrusion or backward extrusion or reverse extrusion. Okay. So this is there, indirect extrusion. And here it is generally used for a hollow cross section, generally. Sometimes for a solid cross section, sometimes for a hollow cross section. There are certain limitations. Lower rigidity. Rigidity means how strong it is, how much forces it can. So because it is not going in the same direction, it has to come back. So the rigidity is low. And difficulty in supporting the extruded product, because there the product was going in that direction. So 5 meters, 6 meters of the product could be there on tables. Here the product is coming back in the direction of the ram, right? Ram is pushing here and it is coming back. So you cannot have very long lengths. The length that comes back is short because this is the press area. Here you have the press, and that is pressing it, isn't it? So therefore these two limitations, that because it is not going out so in the same direction, so therefore on the run out table is not there, it is coming back. So the product length is short and the strength of the whole setup is a little lower the previous one. So these are, but it has its own very important uses. So here we are schematically showing you that this A system, again, right, the force is coming here and the material is going back there, right? So work billet is there, the die is there. So, right, the ram is hollow. The ram is hollow because it is around, this ram is hollow, and in the middle, from the gap in the ram, it is coming back. This is the same system again. You have the container, you have the work billet, you have the die, right, and the final work shape. So if you see here, now this time the ram is here and the material is coming back here. Do you understand? Material is coming back here. There the ram is outside and the material is coming inside. So in this setup, by using indirect or backward extrusion, we are doing a solid extrusion. This time we are doing a hollow extrusion. So we can make this type of a system, right? In one, the ram is solid. So the material that flows around the ram backward is a hollow material. If the ram is hollow, then the material that is flowing back into it is solid. So we can use indirect or backward or reverse extrusion for both hollow and solid shapes, right? This is not a very common method. Most common method in the world is direct extrusion, but in some places they use this also because of certain advantages. Hydrostatic. Now hydrostatic, remember, from your physics and from your fluid mechanics, whenever there is a fluid, which means liquid or gas and so on, then there is a fluid pressure, and that is the same in all directions. So the word hydrostatic is coming from there. So here if you see now, the die is there, the die, special seals are there. The extrusion is coming in this direction. So this is the pressing stem or the ram. This is the container. This is the round container. This is the die backer. This is the die backer. But now between the material and the container there is some fluid. The green area. There is some fluid. So the material is not directly touching the container walls. In earlier, if you go back to direct extrusion, you will see that the billet material is a round shape and it is directly in contact with the inner wall of the container. You are pressing the material, it is going through the container, the material is in the container, but it is pressed, and later on it is pressed through the die. But before the billet material is forced through the die, the billet material is already in direct contact with the wall, inside wall of the container. So at the container billet interface, container billet, there is some friction. Of course, by applying lubricants and so on, and by applying a very high surface finish on the inside of the container and outside of the billet, you can reduce the friction, but that friction is definitely there. Here, they are using some high viscosity liquid as a lubricant, a very thin layer maybe, but that layer is now there between the billet and the inside of the container. So now there is no friction. There is no friction between the billet material and the container. So let me show you again, right? Let me show you again that the material is here, which will be pushed. But this material is not in direct contact with the container. There is some fluid boundary there, lubricant, high viscosity, whatever. So the container is filled with a fluid that transmits the pressure to the billet, which is then extruded through the die. So because the billet material is not in direct contact with the container, so you have removed the friction at the billet container interface. This means that now your press can work with a much lower load. Okay. Now holding the liquid, the lubricant now requires some seals, right? So seals have to be here, seals have to be here, seals have to be here. So here it will complicate the setup by having certain seals and so on. But if you can have that, then you can do the whole process at a much lower load because you are now bypassing the friction force. Finally, impact extrusion. In normal extrusion, which we were showing until now, the load is applied gradually. You see, remember your tensile test. The tensile test, you in material science, you are applying the load on the piece, gradually increasing, gradually increasing, gradually increasing until it breaks. But remember impact test, you are dropping the hammer in the impact machine, so all the load is applied suddenly and it breaks. So in both tension test, tensile test and impact test, you are fracturing the specimen. But in one case, you are gradually increasing the load, and in the other, you are suddenly applying the load. So here also the same thing, that in normal forward or indirect extrusion, both forward, backward, both, the load is applied by the press gradually increasing. But if you suddenly apply the load like a hammer, then it will be impact. So here we are showing you the impact system. This is the material. Here we are calling it a blank rather than a billet. This is the die, one shape, one portion of the die. Another portion of the die is here. Together this and this will make the shape, right? So this is the bottom die, this is the top die. Generally this top die is either called a punch or a cap. Punch or a cap. So the billet material is called a blank, it is here. When this punch presses it, now the material cannot flow that side, so the material starts to flow backwards. So impact extrusion is a backward or indirect extrusion, right? The force is here and the material is flowing back in that direction, right? So this is indirect extrusion, but this comes with a sudden load. It is not gradually, slowly pushed inside. It comes as a punch. Punch means hammer, right? So this is the difference. So now you can read that a schematic illustration of the impact extrusion process. The extruded parts are stripped using a stripper plate, that is later on, as otherwise they may stick to the punch. Two examples of products made by impact extrusion are there. Examples, right? Examples. The most common example, collapsible tubes, the most common example is your Pepsi cans and so on, right? Millions of them are made, but they are impact extrusion, right? There is the bottom die and there is the top die, which is the punch, and it comes with a hammer, boom, and a can is formed, and then second, and then third. But it is indirect extrusion is not continuous. Direct extrusion, after extrusion, a long continuous length is coming. Here, one can at a time, because it will go back, right, in the same direction. You have the press from here, sudden impact load, it will go back in the same direction. So a can will be formed, but it can't go to a very long length. So one can length, and then you push it back, pull it back, put the second piece, boom, second can, third can, fourth can, right? So impact extrusion is also an indirect or backward extrusion process, but rather than gradually applying the load, you apply the load by a hammer load, impact load, as a punch, right? So this is there, and as I said, even if you take just that one example of Pepsi cans and so on, then there are millions of them produced, okay?